Okay, we had some sort of glitch there, but here we are again. So combining the class into dot plot would look something like this. I'm going to draw it really poorly because I'm drawing with my computer screen upright. But it'd be something like this: 0, 1, 2. Actually, these should be proportions. So, like around 0.1, 0.2, 0.3. Excuse the bad handwriting. So then you might have, for instance, in a recent class that I taught, a lot of people had 0 short words. They might have several people who had 0 short words, and then maybe a few people had 0.1 short words, and maybe 2 people had 0.2 short words, and 1 person had 0.3 short words, and so on and so forth. So whatever, you should have as many dots as there are students in our class who answered that question. So that is an example of a dot plot, except you can do it with better handwriting because you'll be writing on, you can write it on paper, like writing down, and you can add a picture then, take a picture on your phone and add to the document. Okay. Or you can use a spreadsheet or any other software you like and make a really nice looking dot plot, whichever you choose. So number 7, what label would be along the horizontal axis of this graph? How many dots do you have? In other words, clarify what each dot represents. All right, I kind of gave you that hint already. Based on the class dot plot, does the sample method tend to produce sample proportions close to the population proportion? 0.41. Justify your answer. So justify, usually you should have the word because or something similar in that, like you should use full sentences. Okay, now you read about biased and unbiased sampling methods, and so I guess you could say, I don't want to jump ahead. All right, so if we're consistently overestimating or consistently underestimating a parameter, that means our sampling method is biased. So does asking you to quickly select 10 representative words appear to be a biased or unbiased sampling method? Well, if you're like most classes, it ends up being biased, but it's hard to tell. So look at the dot plot. Explain why we might have expected the sampling method, asking you to quickly pick 10 representative words, to be biased for this variable. Do you think that if we'd asked each of you to take 20 words instead of 10, it would have helped in regards to the bias? This is so explain, you should be using some full sentences, and this is a question getting at if you truly understand what bias is. Number 12, suggest another technique. So again, if you're having trouble with number 11, go back to the definition of bias and look at that. Okay, so number 12, suggest another technique for selecting 10 words from this population in order for the sampling method to be unbiased. So here you should do some sort of method. So lay it out, like steps to do for how to pick words truly randomly without humans, we tend to think we're random, but we're not. We're not very good at being random. So find a way that would help people be random. Okay, so the key idea of the simple random sample ensures that every sample of size n is equally likely. That way we can do statistics on it. If you're not doing that, convenience samples basically relying on human judgment and what's nearest at hand. A convenience sample is a non-random sample population. So for instance, you trying to do a survey, just going to alpha, picking a few people that you think you're picking randomly, but it's a convenience sample. So, okay. Now we're going to do it a little bit better. So we're going to go to the random number applet. Okay, so now we are looking at the random number applet, and we can go to, so this is a different applet, so we can go here. You can follow the link there, or you can go to here and let's see, where's that random number? Randomizing subjects, sampling words. Okay, sampling words is what it's called on that applet page. Okay, specify that you want 5 numbers per replication in the sample. So number of replications. No, this is the wrong one. I want random number generator. That's what I want. Okay, number of replicants 1, numbers per replicant 5, number range 1 to 268. Okay, and then generate. So I generated 5 random numbers. So then I would write them down. I am going to write them down so I can remember them. Mine should be, you should not get the same numbers that I get. If you do, generate them again. 140, 34, and 178. Okay, so then using your randomly generated numbers, look up the corresponding word from the sampling frame. So then I would look up, so 245, you'd go down to 245, and that's the word have. So it has 4 letters, so it's not short. And then 118, you go pick whatever number you have. So I have 118, which is ground, which is longer. Ground, I forgot to count the letters. 118 ground, 1, 2, 3, 4, 5, 6, 7. So then 7, no. 140. So go down to 140, which is which is 3. So yes. And then for number 4, that's number 30, the 34th word. 34th word is R, so that's 3. So yes. And then again, sorry for the bad handwriting, I'm trying to write with the computer screen up. 178. 178 is who? So that would be another 3. So yes. Okay. So what was I asked to do there? So fill the data table below. So I'm done with that. And then examine your sample of 5 words. So calculate the proportion of short words in your random sample. Again, produce a dot plot of the distribution of proportions of short words for your sample and those of your classmates. Make sure you label the horizontal axis appropriately. Comment on how the distribution compares to your class's dot plot sample proportions. Does the second method appear to be unbiased sampling method? How are you deciding? So for online versions of this class, we're gonna maybe skip. So if you're taking this class online, then skip these because it's too much work to try to get stuff from class for 2 things. So we're going to do the sampling words applet. So sampling words applet, the one I went to accidentally at first. Okay. Use the variable pull down menu, choose short. So variable short, and then confirm the population proportion is 0.41. That's right, 0.41. Check the show sampling options box. Show sampling options. And so then specify 5 number sample size to be 5, and then number of samples. Number of samples 1, so draw samples. Words appear in the box below. And then, so my p hat there would have been 0.2. So then, press it again. So draw samples again. Did you get the same sample this time? Did you get the same sample proportion? So you probably didn't get the same sample. You maybe got the same proportion, maybe not. I did not. So suppose you take 1,000 different random samples and Examine the distribution of the 1,000 sampled proportions. Where do you think this distribution will be centered? What shape do you think it will have? Predict the largest, smallest value. So let's think about it. So if the population has a true proportion of 0.41, and you sample 5 a bunch of times, 5 words completely randomly, where do you think they're going to be centered? What shape do you think all those dots are going to have? Okay. So a sampling distribution is the distribution of a sample for all possible samples of size n randomly selected from a population. So by taking lots of samples, you can approximate the sampling distribution. Okay, so this kind of lays it out. Population is all 268 words. Parameters, the proportion of words in the populations are short. Samples 5 randomly selected words. A statistic is p hat of the proportion of those 5 words. So the mean of the sampling distribution of sample proportions for all possible simple random samples from a population with success proportion pi will be equal to pi. Okay, so that's one of the key ideas from this section. Oh, I can't underline well. Yeah. Anyway, based on what we learned about the sample proportion previously, you should not be too surprised that the distribution of sample proportions you produced is somewhat symmetric. So, I mean, if we come over here and do, say, 1,000, and draw samples, look at that. All right, so verify that the standard deviation of your 10,000, we gotta do 10,000. Let's do 9 more thousand. Draw samples, okay. So, so to verify is to do this formula right here with your numbers and show that that is the same as the number that you're getting over here. With the do this formula and show that you're getting this number, like the 0.216. That's how to verify. Okay. Then going down to 19, how would our prediction of the behavior, shape, mean, largest, smallest value of the distribution of sample proportions change if the population size had 2,680? Okay, so if we had more words, but we basically had the Gettysburg Address like copied 10 times basically, how would that change those 3 things? So tell me about each of those 3 things. Okay, name 2 things that do not impact the standard deviation of the distribution of sample proportion. So that's number 19 and number 20 are related. In the applet, select the radio button labeled fixed, then change the sample size from 5 to 10. Okay, so fixed. And then, so in the applet, select the radio button labeled fixed. Okay. Show sampling options. Fixed. Okay. So, then change the sample size from 5 to 10. And the number of samples to 10,000. Press the draw samples. So, fixed population rescale, fixed. Okay. So, does the standard deviation change as you predicted? Okay. So, and then repeat it for sample size of size 20. Okay. So then 20. So then the central limit theorem is basically saying, and we're seeing this again, is saying that as your samples get larger, there's less standard deviation in the sampling distribution. So does a normal approximation appear to be valid here? Overlay normal distribution. Okay, so do that and tell me if it looks valid. So then other considerations, there's a couple key ideas. So non-sampling concerns. Suppose we were not able to accurately measure the lengths of the words. So those are non-sampling concerns can be things like not being able to measure things accurately. So for instance, like the phrasing of a survey question, things like that. Okay, so then for number 24, as part of the General Social Survey in 2018, a random sample of U.S. adults were asked whether at least one of their grandparents was born outside the United States. In the sample respondent of 2,214 respondents, 881 said yes. So this is the problem that's going to look at your, you're going to need to use your wisdom, your common sense here. So first there's kind of the basic stuff, parameter of interest, statistic and words. So do you think it's generalizable? So a key thing to think about there is like, what is this survey? Do they have a history of doing things well? You can Google the GSS. Maybe look at the Wikipedia page of the GSS and tell me if they seem like a legit organization. Then, so that's a question for C. So for D, suppose we assume the population proportion is 0.5. If we would predict the behavior of the distribution of sample proportions, what do you predict for the mean, the standard deviation, the shape? So the mean is an easy question, right? The shape is a fairly easy question because it's kind of rough. Standard deviation, we have a formula, so use that formula. Okay, so based on the observed sample proportion, is it plausible the observed sample came from a population with 0.5? So plausible is about, is it possible, right? Not only possible, but is it likely, right? Is it not unlikely? So, yeah, that's a question that's, you need to use your wisdom, your critical thinking. So here, okay. Yeah, so you should be looking at the bell curve basically for that question. All right, and then do you have any reason to suspect respondents could be giving misleading information to this question? Okay, use your wisdom, your common sense, your knowledge of what's going on in the news to answer that question. All right, that completes this section.